So in this segment, let us solve a few trigonometric identities. This is the first one. I notice that on the left hand side, I have 1 minus sine square a by 1 plus cos a. So one thing that comes to my mind is, let us take the LCM on the left hand side. So this one has a denominator of 1. So the LCM is going to be 1 plus cos a. And the numerator is going to be 1 plus cos a minus sine square a, right? So 1 plus cos a gets multiplied by 1. So you get 1 plus cos a. And then you have minus sine square a. So now I can group a few terms together. I can write this as 1 minus sine square a plus cos a, the whole divided by 1 plus cos a, right? This is 1 plus cos a. Now 1 minus sine square a can be written as cos square a. So this is cos square a plus cos a, the whole divided by 1 plus cos a. And the identity that I will use in this particular case is sine square a plus cos square a is equal to 1. So now from the numerator, I can take cos a out as common, and inside I am left with 1 plus cos a. And in the denominator also, I am left with 1 plus cos a. Now 1 plus cos a cancels, and therefore I get cos a, which is the RHS. So this is one way of solving this particular question. Now I am going to solve the same question using another method. What I notice is, in the numerator, I have 1 minus, so I have sine square a in the numerator divided by 1 plus cos a. So what I am going to do is, I am going to convert this sine square a into 1 minus cos square a, okay, divided by 1 plus cos a. So which identity did I use over here? I used the identity sine square a plus cos square a is equal to 1. So this therefore becomes 1 minus cos square a can be written as 1 minus cos a multiplied by 1 plus cos a, the whole divided by 1 plus cos a. So because of this, what happens is 1 plus cos a gets cancelled from numerator and denominator, and therefore I can write this as 1 minus bracket 1 minus cos a. I can now open up the brackets, which is 1 minus 1 plus cos a. 1 minus 1 cancels, and therefore I get cos a, which is the RHS. So I notice over here that there are two methods to solve the same question, and I have used sine square a as 1 minus cos square a in both places. So this is how I can solve this question. I am pausing for a couple of minutes so that you can take a look at both these strategies, and then we will go on to our next question. Okay, let us now go to the next question. So this is the next question that I would like to solve. Let us look at the left hand side. I have cot square a cosec square b. So over here I have two different angles a and b. So I have cot square a cosec square b minus cot square b cosec square a. And on the right hand side I have only cot square and cot square a and cot square b. So there is something that comes to my mind. In this particular question, maybe what I should do is, I should take my left hand side, which is cot square A cosec square B minus cot square B cosec square A. Okay, so let's take the left hand side. And wherever I see a cosec square, I am going to convert it into a cot square. The reason for that is, I see that in my RHS, I don't have this cosec square anywhere. So I will write this as cot square A, and cosec square B can be written as 1 plus cot square B, right? So 1 plus cot square is cosec square minus cot square B multiplied by cosec square B is 1 plus cot square A, right? So what is the identity that I've used here? I've used 1 plus cot square theta is cosec square theta. Okay, so time to open up the brackets. This becomes cot square A plus cot square A into cot square B is cot square A cot square B minus cot square B into 1 is minus cot square B, and minus cot square B minus cot square A is minus cot square B cot square A. So now you will notice that cot square A, cot square B terms cancel. So these two terms cancel. And the final answer that I get is cot square A minus cot square B, which is the RHS, right? So the strategy that I used here was, because I didn't see a cosec square term in the RHS, I decided to convert all cosec square terms into cot square terms in the LHS. Again, let me pause for a couple of minutes and then we will continue. Okay, let us now take the next question. So this is the next question that I wish to solve. I notice that I have 1 plus sine minus cos in the numerator and 1 plus sine plus cos in the denominator, and it is whole squared. So there are three terms here. Let me start off with my LHS. So my LHS is 1 plus sine minus cos the whole square divided by 1 plus sine plus cos the whole square. So this is basically a trinomial. If there are three terms in 1 plus sine minus cos, and that is squared. So I need to remind myself of the formula a plus b plus c the whole square. So let us write that formula here. A plus b plus c the whole square was given by, so a plus b plus c the whole square was given by a square plus b square plus c square plus 2ab plus 2bc plus 2ca. So now I am going to use this formula in both places, numerator as well as denominator. So this becomes 1 square plus sine square theta plus c square, which is minus cos theta the whole square, plus 2 times 1 times sine theta plus 2 times 1 times minus cos theta plus 2 times sine theta times minus cos theta, the whole divided by, now let's take a look at the denominator. The denominator is now going to be 1 square, which is 1, plus sine theta the whole square, which is sine square theta, plus cos square theta plus 2 into 1 into sin theta plus 2 into 1 into cos theta plus 2 into sin theta into cos theta. So therefore this becomes 1 plus sin square theta plus negative cos theta the whole square is cos square theta plus 2 sin theta minus 2 cos theta minus 2 sin theta cos theta the whole divided by sin square plus cos. So again 1 plus sin square theta. Let me first write all the terms properly. Plus 2 into 1 is 2 times sin theta plus 2 into 1 is 2 times cos theta plus 2 into sin theta into cos theta, right? So these are the different terms that I have. Let me pause for a few seconds so that you can see the a plus b plus c the whole square expansion. Okay, so now in the numerator and denominator, both places, I notice a sin square plus cos square, which is 1. I notice a sin square plus cos square, which is 1. So 1 plus 1 becomes 2. So 2 plus 2 sin theta minus 2 cos theta minus 2 sin theta cos theta, the whole divided by again I have sin square plus cos square is 1 in the denominator, 1 plus 1 is 2. So 2 plus 2 sin theta plus 2 cos theta plus 2 sin theta cos theta. Now let's consider factorization. From the first two terms 2 is common. So 2 times 1 plus sin theta. In the next two terms minus 2 cos theta is common. So minus 2 cos theta times 1 plus sin theta, the whole divided by 2 times 1 plus sin theta plus 2 is common in the denominator. So 2 cos theta times 1 plus sin theta. Now you will notice that 1 plus sin theta is common in the numerator. So I am left with 1 plus sin theta into 2 minus 2 cos theta. And similarly in the denominator also, I have 1 plus sin theta left and I get 2 plus 2 cos theta. Now 1 plus sin theta cancels from both numerator and denominator. So this term goes away and I am left with 2 minus 2 cos theta divided by 2 plus 2 cos theta. 2 is common, so 2 bracket 1 minus cos divided by 2 bracket 1 plus cos. 2 cancels and therefore I am left with 1 minus cos theta divided by 1 plus cos theta, which is actually equal to the RHS, right? So therefore I have the concepts that were used in this particular problem were the right expansion of a plus b plus c the whole square, and of course there was a lot of factorization that was used in this particular problem. Also over here, because I have used sin square plus cos square as 1, I should be mentioning here that I have used the identity sin square theta plus cos square theta is equal to 1. So this is how I solved this particular question. Again I am pausing for a few minutes so that you can all see what was done. Okay, let us continue with the next question now. So in this particular question, my left hand side is tan square A minus tan square B. Again, I notice that there are two different angles A and B. And my right hand side is completely in terms of sine and cos terms of both the angles. So what I'm going to do is I'm going to first take my LHS, and because the RHS contains only sine and cos terms, I'm going to convert tan square A minus tan square B into sine and cos terms. So this becomes sine square A becomes tan square A becomes sine square A by cos square A, and tan square B becomes sine square B by cos square B. And when I take the LCM becomes cos square A cos square B. So the LCM is cos square A cos square A cos square B, and the numerator is sine square A cos square B minus sine square B cos square A. So this is what I get after finding the LCM. Now I am happy with the denominator because that is what I need. I need cos square A cos square B in the denominator. However, I am still not happy with my numerator because the numerator doesn't match. In the RHS, I notice that there is no cos square term. So what I am going to do is I am going to convert all the cos square terms into 1 minus sine square term. So cos square B is 1 minus sine square B minus sine square B times cos square A can be written as 1 minus sine square A, the whole divided by cos square B times cos square A times cos square B. So now again I can open up the brackets. So when I open the brackets, I get sine square A minus sine square A sine square B minus sine square A sine square B. Then minus sine square B into 1 is again minus sine square B, and minus sine square B into minus sine square A is plus sine square A sine square B, the whole divided by the denominator, which is cos square A cos square B. Now in the numerator, you will notice that I have a positive sine square A sine square B and a negative sine square A sine square B, which will cancel, and therefore I am left with sine square A minus sine square B divided by cos square A cos square B, and this is precisely what I require in the RHS. So this equals RHS, hence proved. Hence I have proved this particular identity. So again I'll pause for a few minutes. The main idea here was, because my RHS had only sine and cos terms, I decided to convert my LHS into sine and cos, and then LCM helped me, so I got the same denominator. And in the numerator, I saw that I don't need cos square terms, so I converted cos square into 1 minus sine square. Okay, so these were the different techniques that were used in this particular problem. Okay, let us continue with the next question now. Okay, this is our next question. Again, I have three terms to prove here. The first one is 1 plus tan square by 1 plus cot square. Wait, there was an identity for 1 plus tan square and there was an identity for 1 plus cot square, if I remember correctly. 1 plus tan square was sec square and 1 plus cot square was cosec square. So what I can do is I can take my left hand side, okay, and in the left hand side I can now start with 1 plus tan square theta divided by 1 plus cot square theta. Now I know that 1 plus tan square is going to be sec square theta and 1 plus cot square is going to be cosec square theta. Now sec square theta can be written as 1 by cos square theta and cosec square theta can be written as 1 by sin square theta. Therefore, this becomes sin square theta divided by cos square theta, because division of fraction means I should take the reciprocal of the denominator and multiply it with the numerator. So this becomes sin square by cos square, which becomes tan square theta. So you will notice that I have showed that the first term is indeed equal to the last term. Okay, so the first part is complete. Now the second thing that I should be doing is I should show that this 1 minus tan theta upon 1 minus cot theta the whole square is also tan square. So what I'm thinking of is, I know that cot is 1 by tan. By the way, my RHS is tan square, isn't it? So I am going to convert my cot into tan and let's see if that helps me. Okay, so let me just make a partition here. Alright, so I have 1 minus tan theta upon 1 minus cot theta the whole square. So let me convert this cot to tan. So I can write this as 1 minus tan theta divided by 1 minus 1 by tan theta the whole square. So this therefore becomes 1 minus tan theta divided by tan theta minus 1 by tan theta the whole square. And therefore this is 1 minus tan theta divided by tan theta minus 1 multiplied by tan theta the whole square. Therefore this becomes 1 minus tan theta upon tan theta minus 1 the whole square multiplied by tan square theta. Right? So I have split the squares. The square was applicable for this term. The square was applicable for this term as well as for this term. So I have split the two squares here. Now you will notice that 1 minus tan by tan minus 1 is actually negative 1, because I can take a minus common from the numerator and then the numerator and denominator will cancel. So this is negative 1 the whole square times tan square theta. Now negative 1 square is positive 1, therefore this becomes tan square theta, and therefore all the three terms are equal to each other. This is how I can prove this particular identity. I used a few identities directly. If you notice the left hand side, I directly used the identities and I showed that it was equal to tan square theta. And on the second part, I saw that converting cot into tan actually helped me simplify the answer. So let me again pause for a few minutes for you to take a detailed look at the solution and then we will continue. Okay, let us now continue with our next problem. Okay, so in this question, the left hand side is cosec minus sine into sec minus cos is equal to 1 by tan plus cot. So the left hand side has all sines and cos, and I can convert the right hand sides also into sine and cos. So in this particular problem, I am going to convert both left hand side and right hand side into terms of cos and sine. So let's take the left hand side. So the left hand side is cosec theta minus sine theta times sec theta minus cos theta. So this becomes cosec theta becomes 1 by sine theta minus sine theta, and sec theta is 1 by cos theta minus cos theta. So therefore, if I take the LCM in the first bracket, I get sine theta, and I have 1 minus sine square theta. And in the second bracket, I have 1 minus cos square theta divided by cos theta. I know that 1 minus sine square can be written as cos square theta upon sine theta, and 1 minus cos square can be written as sine square theta upon cos theta. Now you will notice that one sine from the numerator will cancel and one cos from the numerator will cancel, and both sine and cos from the denominator get cancelled. So this therefore becomes sine theta times cos theta. So this is my left hand side. Now I am going to go ahead and convert the right hand side into terms of sine and cos. Okay. So I have right hand side is 1 divided by tan theta plus cot theta. That is 1 divided by, now tan theta can be written as sine theta by cos theta, and cot theta can be written as cos theta by sine theta. The LCM of the denominator is sine theta cos theta. So sine theta cos theta. The numerator is sine into sine, which is sine square theta, and cos into cos becomes cos square theta. Therefore, this is equal to 1 divided by 1 by sine theta cos theta, because the identity used is sine square theta plus cos square theta is equal to 1, and therefore I get sine theta cos theta as my RHS. So I have showed that both sides are equal to sine theta cos theta, and sometimes in some problems you have to go from LHS to RHS. In some problems you will notice that we have gone RHS to LHS, whereas in some problems you will take both the left hand side and right hand side. You will simplify them and bring them to an equal value. When you bring them to an equal value, you can definitely say that both my sides are equal and therefore LHS equals RHS. So that is the strategy that we used in this particular problem. I was forced to use this strategy because I noticed that everything can be expressed in terms of sine and cos, and that greatly simplified my problem. So I am pausing for a few minutes now for you to take a look at the solution, and then we will continue that. Okay, let us continue with the next question now. So in this question, I notice that in the left hand side, I have cot and tan of different angles, and on the right hand side, I specifically have cot A and tan B. Okay. So now I am going to think about how to solve this problem. On the left hand side, I have cot A. On the right hand side also, I have cot A. So let me not disturb the cot A term because I need it in the RHS. In the LHS also, I have tan B term. RHS also, I have tan B term. So I don't want to disturb the tan B term either. But the cot B and tan A terms in the denominator are definitely what I don't want in the RHS. So what comes to my mind is, take the left hand side. Okay. The left hand side is cot A plus tan B. Cot A plus tan B divided by cot B plus tan A. Right. And now what I'm going to do is, let me leave the cot A term as it is. I have it in the RHS. Let me leave the tan B term also. I have it in the RHS. But the LHS, let me now convert the cot B into 1 over tan B because I want tan B in the RHS. And let me convert tan A into 1 by cot A. So therefore, this is now equal to, the numerator is cot A plus tan B divided by the denominator now is going to be tan B cot A, and after taking the LCM, right now I am simplifying the denominator. So pay all your attention towards the denominator. So the denominator's LCM is tan B cot A, and the numerator of the denominator will be cot A plus tan B, right? So now what I have is, I have division of two fractions. This is one and this is the other fraction. I know that when fractions have to be divided, I should be taking the reciprocal of the denominator and multiplying it. So what is the reciprocal of the denominator? The reciprocal of the denominator is tan B cot A divided by cot A plus tan B, right? And therefore the terms cot A plus tan B can now cancel, and what I now get is tan B times cot A, which is equal to the RHS, right? And therefore my LHS equals RHS is true. So over here I was keeping a watch on which terms I needed, and the undesired terms, which were cot B and tan A in this case, I converted them into tan B and cot A. Pausing for a few minutes for you to take a look at this solution. Okay, let us now continue with the next solution. Okay, these are the next two questions that I am supposed to solve. We have tan square theta minus sine square theta. We have to prove that it is equal to tan square theta into sine square theta. So let us see how to go about this particular solution. My left hand side right now is tan square theta minus sine square theta. So what I'm going to do is I'm going to write tan square theta as sine square theta divided by cos square theta minus sine square theta, right? Now I can definitely take out sine square theta as common. So I get sine square theta into 1 by cos square theta minus 1. Therefore, this becomes sine square theta. I know that 1 by cos square is going to be sec square theta. So it is sec square theta minus 1, which is therefore equal to sine square theta into tan square theta. So this is how I solve the question. This is one way of solving the question. There is another way that I can show you. So I have my left hand side, which is tan square theta minus sine square theta. Now tan square theta can be written as sine square theta upon cos square theta minus sine square theta. I can take the LCM. So the LCM is going to be cos square theta. The numerator will be sine square theta minus. Now this sine square gets multiplied with cos square. So it becomes sine square theta cos square theta. What is common in the numerator? Sine square theta is common in the numerator. And I am left with 1 minus cos square theta divided by cos square theta. Now sine square theta by cos square theta is tan square theta. And 1 minus cos square theta is sine square theta, and therefore this is my RHS. So I was able to solve this particular question in two different ways, and I noticed that factorization definitely is a very powerful technique, which was used in the first case, taking out sine square out as common. And in the second case, I first found the LCM and then I took sine square out as common. So factorization and LCM are two powerful techniques that are illustrated in this particular question. So let me again pause for a minute for you to take a look at the solution, and I will continue with the next one. Okay, let us now continue with the next question. In the next question, we have three terms that have to be proved to be equal. Let's first look at sec theta minus 1 upon sec theta plus 1 equal to 1 minus cos by 1 plus cos. So I have to now prove that sec theta minus 1 divided by sec theta plus 1 is equal to 1 minus cos theta upon 1 plus cos theta. So let me start with the left hand side. I notice that in my left hand side I have sec, which can be expressed in terms of cos, and the right hand side actually has only cos terms. So I guess a good technique to be used would be to convert sec to cos. So sec theta can be written as 1 by cos theta minus 1 divided by sec theta is 1 by cos theta plus 1. I can now find the LCM. LCM of the numerator is cos theta. So I get 1 minus cos theta. That is what I get in the numerator. Divided by, look at the denominator. In the denominator also the LCM is cos theta. So the term becomes 1 plus cos theta, the whole divided by cos theta. This is now division of two fractions. So what I've got is, I've got 1 minus cos theta by cos theta divided by 1 plus cos theta divided by cos theta. So this therefore becomes 1 minus cos theta divided by cos theta into cos theta divided by 1 plus cos theta, and therefore my answer is 1 minus cos theta divided by 1 plus cos theta, which is equal to the RHS, and this is what I wanted to prove. So I noticed that converting sec to 1 by cos actually helped me, and I was able to get the answer easily. Division of fractions was one of the concepts used here, and of course finding the LCM was the other. Now let us see if I can prove the second part. So let me draw a quick partition over here. So I notice that in the RHS, I have sine theta upon 1 plus cos theta the whole square, right? So my RHS is sine theta divided by 1 plus cos theta the whole square. Let me assign squares to both, which is sine square theta divided by 1 plus cos theta the whole square. So sine square theta can be written as 1 minus cos square theta divided by 1 plus cos theta the whole square. 1 minus cos square theta can now be written as 1 plus cos theta multiplied by 1 minus cos theta. The concept that I have used here is a square minus b square, and the denominator is 1 plus cos theta multiplied by 1 plus cos theta, right? So now what happens is 1 plus cos theta cancels from both numerator and denominator, which is why what I now get is 1 minus cos theta divided by 1 plus cos theta, and that equals the LHS, right? So if I consider the second term and the third term, then 1 minus cos by 1 plus cos is LHS. So I have shown that the two extreme terms, that is sec theta minus 1 by sec theta plus 1 and sin theta by 1 plus cos theta the whole square, I have shown that both these terms equal 1 minus cos by 1 plus cos. So this is how I was able to solve this particular question. Let me again pause for a minute and then I will continue with the next problem. Now before I go to the next question, I would like to show you something, some technique that comes to my mind. when I look at question number 2. So over here, so let's just erase everything. Right now, when we proved the following questions, we saw that I went from sine theta by 1 plus cos theta the whole square. So I'm specifically thinking about when I solved this particular identity, I went from the RHS to LHS. I'm now curious as to can I go from the LHS to the RHS, right? So suppose I start with 1 minus cos theta by 1 plus cos theta. Can I go to the RHS that is shown over here? So if I carefully notice the two terms, you will notice that I have 1 plus cos in the whole square in the denominator, right? So look at the denominator of the left hand side, it is 1 plus cos. Look at the denominator of the RHS, it is 1 plus cos the whole square. So what I'm going to do is I'm going to multiply both the numerator and denominator by 1 plus cos theta. So what happens because of that is the numerator becomes 1 into 1 plus cos becomes 1 minus cos square theta, and the denominator is 1 plus cos into 1 plus cos becomes 1 plus cos theta the whole square. So 1 minus cos square theta is sine square theta, and sine square theta divided by, in the denominator I have 1 plus cos theta the whole square. So the numerator and denominator are having a whole square. So we get sine theta by 1 plus cos theta the whole square, which is equal to the RHS. So this is one more thing that I noticed, that sometimes just looking at the terms very closely can be a good hint of what to do. I saw that my LHS had 1 plus cos theta and my RHS had 1 plus cos theta the whole square. So multiplying the denominator by 1 plus cos theta was a great idea, right? So sometimes for solving trigonometric identities, just spending a minute in looking at the LHS and RHS can really help you. So this was the point that I was trying to drive in this example. Let me now continue with the next example. So the technique used here was a plus b the whole cube, and I showed the solution using both the formula of a plus b the whole cube, and it was found that in this situation using the second formula was much better. So let me pause for a minute, and I think we conclude today's session. I'll pause for a minute if there are any questions. Okay, thank you.